So as everyone joins, you'll just see some a slideshow of some former artists in residence's work at the Pine Needles cabin.
Hi, everyone.
Hey, Amy.
It's great to see you all.
Just a note, everyone is muted who has just joined, but you can feel free to chat in the chat window and turn your cameras on. That's just fine.
Welcome, Harpers. Bill, good to see you too.
Okay, welcome everybody. We're just going to give a minute or two more just to make sure everyone gets here on time, and then we'll start the program. Okay, hello. I'm Adam Heathcote, a senior scientist at the St. Croix Watershed Research Station. Welcome to our first and hopefully only virtual Friends event. I know this isn't as fun as having wine and hors d'oeuvres in the lobby of the research station, but we hope to be getting back to that soon. We're so glad you're here with us tonight. Support from the Friends is an essential part of the work and the community engagement that we do at the research station. We have a great program tonight with scientists and leaders from across our organization. We're really excited to finally be able to share some updates and new projects at the research station and also enjoy a great conversation with you. We've missed you all. Just a couple Zoom notes. You're probably all Zoom pros at this point in your lives, but we'll be running this program with a few different presenters, and the best way to see them is by choosing the speaker view in the upper right of your Zoom screen, so that'll spotlight who's ever presenting at a given moment. All guests will be muted during the program, but there will be time for a Q&A at the end of the program. And also at any time, anytime anything pops into your head throughout the entire program, please feel free to use the chat window in the bottom to share your thoughts and questions to the moderator. All those questions will be saved for the end. So don't risk forgetting your question. Just put it in as soon as it comes to your mind. And please do, because that's always the most, as a presenter, it's always the most interesting part of any program is always answering the questions from you all. So now to start the program, I'd like to introduce a co-host who many of you have met at previous in-person Friends events, Alison Rempel Brown, the CEO and president of the Science Museum of Minnesota. Alison.
Thanks so much, Adam. And it is great to be here. And I agree. I hope it's the last time we have to do it via Zoom. And we all are here because we care about Minnesota's beautiful waterways. And it's really evident when we talk about the St. Croix Watershed Research Station. We are really fortunate. There was a foresight so many years ago to invest in the critical water research at the station. And this continues to be some of the most crucial work underway within the station and the Science Museum, and really has global implications. Proud the work we set out to do all those years ago continues today. And as Adam said, if you don't know me already, I'm Alison Rempel Brown, President and CEO of the Science Museum of Minnesota. And I'm really looking forward to being with you tonight and looking forward to being with you in person. And I really hope that can happen soon and science allows us to all gather together again safely. And thank you for everyone watching tonight. And thank you for your support of the St. Croix Watershed Research Station. I've met many of you in person, and I look forward to doing that again soon. With your support, our scientists and advocates continue to better understand the challenges facing our most precious resource, clean water. And as we discussed tonight, because of the quick and thoughtful action by our team at the research station and our Chief Financial Officer, Barry Gisser, our new conservation easements will expand our research opportunities in the future, and you'll learn more about that later on. And we remain hopeful there will be successful resolution to the impasse at the legislation that supports the science our researchers do. We know this group of friends is among the St. Croix Watershed Research Station's most enthusiastic and committed supporters and have been for decades and decades. And I want us to stay in touch about what's next. So tonight we pledge regular updates for friends of the research station to grow our relationship with each of you. And now to share updates about our work at the Roger Station, I'll hand it to our Chair of Science, Lori Fink, to share updates and plans for the future. I look forward to our conversation and Q&A at the end tonight. Thank you.
Hi, it's so great to see so many of you again and to be here together. And I look forward to seeing you in person sometime soon. So I'm Lori Fink. I'm the Chair of Science at the Science Museum, and I have the privilege to lead our work in the Center of Research and Collections. It was a challenging year in 2020, but thankfully we started off 2021 in a planning mode, and we're planning for the future. This continued planning will lead us to a more sustainable and viable funding model. And we are hoping to continue, or we will continue our impactful and mission-driven research. And as you just heard a teaser for, conserving the land that the research station is on for many generations to come. I look forward to meeting many of you again in the future and in person. And tonight, you're going to hear directly from some of our research station staff about our current projects. But before I hand it over, I too really want to thank you for your support, because it's your support that allows us to keep our facilities and equipment in working order when we can, so that we can conduct this very important research. And as you know, it's our goal to keep the lakes and rivers we treasure healthy. So I look forward to connecting with all of you and more as we move forward. At this point, I'll hand it back to Adam so he can talk more directly about our work.
Thanks, Lori. Okay, so I'm just going to give a few kind of specific updates, because I know one thing that a lot of you are probably interested in is just what have we been up to for the last 17 months. And we definitely haven't been sitting and twiddling our thumbs. But first thing I want to say is a big thank you to one of our primary sponsors, Polaris, who donated the main research vessel that we use for all of our work, specifically on big lakes and Lake of the Woods, and hopefully on nearshore Lake Superior in the near future. Can you go to the next slide, please, Guy? I know some of you may have seen a preview of this boat, well, God, 2 years ago now or something like that. But this is the final product. You can see we've christened it the Navicula. It's a diatom. So you can guess Mark Edlund had a hand in picking that name. I think it means, Mark could correct me on it, but it means something like little boat in Latin. So it's a big boat, but we still like the name. So what have we been up to with this boat over these last few months? Well, we were fortunate. A lot of research groups were not able to even get a field season in 2020. And you know, thanks to us getting back up and running early in June, we were able to pretty much salvage our entire 2020 field season, which is critical when you think of some of the long-term monitoring projects that we've been a part of, specifically on Lake of the Woods. If you go to the next slide, please, Guy. Here's a photo of us out on probably one of the most spectacular days on Lake of the Woods I think this was in July of 2020. You don't often see glass calm water on a lake that's 30 miles across. So this was just, you know, something to treasure. You can see we had a little bit different field gear on. We did have to mask up for the field season, although the masks actually were quite comfortable for the second part of our field season. If you go to the next slide, Guy. So we also were out in the winter. So this is probably the same spot on Lake of the Woods, but in March instead of in July. So you can see just as far, and the water is just as flat, except for it's frozen at this point. Okay, so some more specific updates. Next slide, please, Guy. We've been busy, and no one has been busier than Elena and Jeremy and Aaron in the water and radiometric laboratory. So in our water chemistry laboratory, we've analyzed something like 730 water and sediment samples over the last year. That's a combination of projects for the National Park Service, University of Saskatchewan, our own work all over the state and all over the country and the world. Aaron Mortensen and I have been working in the radiometric laboratory. So we've dated sediment cores, or 40 different sediment cores from 10 different states, 4 different countries. It's been one of the busiest years in terms of sediment dating that we've had. The scientists have also been busy summarizing and synthesizing their research. We published 11 scientific papers in peer-reviewed journals and technical reports as part of some of the major projects we worked on. And also countless virtual presentations we've given. I tried to count them up, but I just gave up. You know, everything from presenting, you know, helping middle school and elementary school teachers with, you know, virtual content that they were so hungry for when everyone was online, to Mark Edlund hosted weekly Diatom academies where Diatom researchers from around the world would talk about different topics. We reached many different people virtually. And so that was one kind of blessing in disguise of all this, is we really learned how to do that well, which really broadens the people we can reach. And there's more in the future as well. If you go to the next slide, please, Guy. These are just a few projects that we are for sure going to be starting up in the next year. As I mentioned, the big boat will be out hopefully on Lake Superior. We have a project starting up hopefully at the end of this summer, if that legislative holdup is resolved, where we're going to be looking at an exotic diatom or an exotic strain of a diatom called rock snot or Didymosphenia, which has showed up for the first time in the Poplar River on the Lake Superior's North Shore in 2018. We're also entering phase 4 of our Lake of the Woods project, this time working very, very closely with the Red Lake DNR. We were just out today, so if I seem tired or frazzled, it's because I literally just got off Forest Lake just a few hours ago with Mark Edlin putting in our buoys for a new project where we're looking at Forest Lake and Little Comfort Lake, looking at both internal loading of nutrients as well as long-term paleoecological reconstructions. And we have another project working with Cornell University in Ithaca, looking at how small ponds on the landscape can be used as sinks for carbon dioxide. So all kinds of new stuff and many, many more things, which I couldn't share on one slide. So I know one thing a lot of you, especially those of you who live near the station, are interested in, to hear more about is the partnership with Washington County and the Minnesota Land Trust. So to explain first some background on what a conservation easement is and the value of the future work to the research station, I'd like to share a short piece we filmed with one of my colleagues and fellow senior scientists, someone who most of you probably know, Dr. Sean Schottler. And then after him, we'll segue to Barry Gisser, the Chief Financial Officer and Vice President of Museum Infrastructure, to share some details on the plan. So take it away, Sean.
Conservation easement is a legally recognized means of permanently protecting land in some form of its natural state. Very similar, you're familiar with when they put covenants onto properties. A conservation easement is a form of a covenant that is specifically designed to permanently protect land. Conservation easements are important because they're one of the best tools, mechanisms that we have for private landowners to permanently protect their property. So a landowner says they really want to preserve their land. They need a mechanism to do that. A conservation easement is a legally recognized document that is attached to the deed, transferred to all subsequent owners that say typically the development rights are retired for that property. State and federal governments recognize it, and the IRS recognizes that if you donate the value of an easement, it is a charitable tax contribution, and therefore it has federally recognized tax advantages. Working here, I think we always just assumed that the land was protected and was never being developed. But as those of us who work with conservation easements say, land is never preserved until it's preserved. Just because you think you're preserving it, you're never going to develop it, that doesn't guarantee it into the future. And so the legal documentation now, the fact that it's recorded and it's with the deed, makes it protected. And there's some relief and certainty in that. And just in general, I think the feeling for all people who work with conservation easements or work on the land is it's a piece of land now that's preserved, and we get to pass on to the future with allowing them to have an opportunity to do something on the land and appreciate it. And I don't know what that will be necessarily. I mean, the world is going to change, climate change is going to change things, but this as an undeveloped piece of land will be here and available.
Thank you, Sean, for sharing that background and your experience with conservation easements. Good evening, everyone. I'm Barry Gisser, and it is a pleasure to be with you tonight. I'll take you on a quick walk through some of the key elements of the planned research station conservation easement. And first, it's important to know that this project required a long and thoughtful process and a partnership between several like-minded entities highlighted on this slide. Moving into some of the specifics on the next slide, before we get to that though, I just want to share a little bit about the amazing land and property that we're talking about with this project. Think about it, 9,000 feet of shoreline, part of the St. Croix Scenic Riverway, and an incredible diversity of land cover. This is truly amazing property. Getting into some more details on the actual easement on the next slide, the easement covers approximately 125 acres over much of the Science Museum St. Croix Watershed Research Station. It's about 80%. Some of the other land is already used for other purposes and not available to have an easement. Importantly, the museum will retain long-term ownership of the land and continue its important research that Adam and the rest of the team is talking about tonight. The county will co-hold the conservation easement with the Minnesota Land Trust, and MLT will conduct annual monitoring to ensure we're being compliant with the terms of the easement. Division of the land and mining are prohibited, and the easement allows limited commercial and agricultural use, but all current uses will continue. Importantly, trails, roads, docks, and existing structures are permitted, so you will not see significant change to the land as it sits today. And finally, while this is a standalone project, it is related to the Wilder Forest project you may have heard about or read about in a Pioneer Press article just a few weeks ago. Through our unique partnership with the Minnesota Land Trust and Washington County, we can protect this land and also maintain it for research and education purposes. I look forward to your questions during the Q&A. We also plan to share more updates as the project moves along for what is targeted as a July 2021 close. At this point, I'll hand it over to tonight's featured speaker, Joy Ramstack Hobbs. Joy is an associate scientist at the station and has been with the research station since 2005. She's actually currently working remotely from her home in Olympia, Washington, and her work focuses on using lake sediments to infer recent environmental changes. As Joy is speaking, be sure to put your questions in the chat for the Q&A. Thanks, and I'll turn it over to Joy.
Thanks. Hi, everyone, and thank you so much for joining our event this evening. It's really great to have everybody here. I'm going to be giving a short overview of two recent projects I've been working on, from local work in the St. Croix Valley to a large collaborative project with global change implications. You can go ahead to the next slide, Guy. And as Barry mentioned, I've been a scientist at the research station since 2005, but working remotely from Washington State since 2013. So this has been a really interesting year for me, and I probably have a slightly different take on it than others do. Now that everyone's working via Zoom, I've been able to connect and reconnect in new ways, and I'm even here presenting at a friend's event tonight. And in this remote work has also allowed the research station to connect with other science museum departments in new ways. And so before I get into the bulk of my talk, I want to highlight just one of those connections. Next slide. So last spring, when everyone pivoted to remote work and schools were closing, our science education department at the museum was faced with this pretty big task of creating online lessons for schools that they usually visit in person. So Adam Heathcote and I had the opportunity to join a cross-departmental working group to help with that task. And one of the virtual lessons that our science education department created was called What's in Your Stream? And I just pulled a couple of still shots from this virtual lesson that our science education team brought into schools and is now available on the SMM website for anyone to use. And so to create this, samples were collected at a stream on the research station property. So the station and our grounds were really highlighted. I believe Elena had the chance to help with sample collection. Adam and I advised on content, and I provided a video introduction for the lesson. So I think learning how to work together from different locations will really help cross-departmental work in the future. So I just wanted to highlight this as something really positive that came out of this past year. Next slide. So I'm going to be highlighting two projects tonight. I'm going to start local in the Comfort Lake, Forest Lake Watershed District, where it sounds like Adam and Mark were this afternoon. And I'm going to talk about how our work there informs local lake management decisions. And then I'm going to talk about a large collaborative project, the Neotoma Paleoecology Database, where we're making our research station data sets available for global change research. And I'm also going to talk about how those two projects actually kind of link together. Next slide. So we'll start in the Comfort Lake Forest Lake Watershed District, and this is right in the St. Croix Valley, just north of the research station. It's actually on the border of Washington and Chisago counties. We began work on lakes within the Watershed District in 2017. We've completed work on 5 lakes so far. I'm going to just kind of quickly highlight 2 of those this evening. And we've started work on 2 more lakes this spring. Quite a few of the lakes in the Watershed District are considered impaired by Minnesota state water quality standards. Many of those impairments are due to high phosphorus levels. Phosphorus is a nutrient for algae. High phosphorus levels can lead to frequent algal blooms and other impairments. So our work involves collecting sediment cores from the lakes to infer the environmental history over the past 100 to 150 years. And it's really important to know the history of water quality in a lake in order to make well-informed management decisions. And so with our research, we answer questions such as, what was the water quality in the past? If the water quality has changed, when did it change? And in these lakes specifically, have phosphorus levels always been high? And if not, when did they start to exceed our state standards? Next slide. The aim of the work of our work here in the Watershed District is to use dated sediment cores to reconstruct the water quality of the lakes. And if you come to Friends events frequently, you're probably quite familiar with the sediment core work we do at the station, but for others, I'll give just kind of a brief overview of our methods. A sediment core, as seen here in the photo, is basically providing us with a history of what has accumulated in the lake over time. So looking at the photo here, you can imagine the top of the core represents sediment that sort of just settled out of the lake in recent years. And as you move down through the sediments, you're essentially moving back in time. And at the lab we have at the research station, we use lead-210, this naturally occurring radioisotope, to figure out precisely how old our sediments are. We can collect sediments either by augering through the ice, as seen here, or from boats in the open water season. Pictured in the photo here on the left is our colleague Kevin Tyson from the University of St. Thomas in St. Paul, who's been collaborating with us on this work since we started in the Watershed District. And he's pictured here with one of his undergraduate students. One of the really cool things about this project is that it's been a great training experience for quite a few students at St. Thomas. So we have our sediment core and it's been dated. We can then analyze different biological and geochemical markers in the sediment to give us information on past lake conditions. I'm pretty sure over the years you've heard a lot about how Mark Edlund and I work extensively with diatoms. There's quite a few people who have diatoms as a virtual background tonight, so if you kind of look around your screen. Diatoms are a single-celled algae that form a silica cell wall. So this biologically produced glass cell wall preserves really well in the sediments, and we can infer past water quality conditions from the diatom species present in our sediment core. Next slide. And in this project, we're really interested in lake management. We're primarily interested in changes that have occurred in the lake since European settlement. So we're talking kind of the mid to late 1800s in this region. And that's because this is the period of heaviest human impacts to the landscape. Another photo of Kevin and his students from St. Thomas, and this time coring in slightly warmer weather from canoes. Next slide. So I'm going to talk just a little bit about our findings from 2 lakes, Bone Lake and School Lake. In Bone Lake, our sediment core evidence suggested that even though Bone Lake is considered to have high phosphorus levels right now, the water quality of the lake was actually worse from the 1940s through the 1990s. And we inferred this from diatoms in our sediment cores, other algal remains in the cores, and from some direct geochemical analyses of the sediments. These same lines of evidence showed us that there have been trends in improvement in water quality since the 90s. And in fact, Bone Lake is now poised really close to the Minnesota water quality standard of 40 parts per billion of total phosphorus. Next slide. So our recommendation to the Watershed District was to continue the efforts they've been making to reduce their phosphorus inputs to Bone Lake. And this should maintain this recent trend of improving water quality. We feel that continuing with the current efforts they're making in this watershed, they'll keep the lake below the state standard of 40 parts per billion of total phosphorus, and it might potentially allow the district to actually meet their goal, which is a bit lower than the state standard of 30 parts per billion of total phosphorus. Next slide. So the story in School Lake was a little bit different. So we're using the same multiple lines of evidence in our dated sediment cores. And here we found that School Lake has actually been high in phosphorus over the period we examined. So for the past 100 to 150 years. In fact, it seems the lake was even higher in phosphorus in the 1940s and 50s. And there's been a bit of a recovery trend since the 1960s. And the current phosphorus levels in the lake are similar to what was seen in the 1920s and earlier. Next slide. So our management recommendations for School Lake were different than those for Bone. We do recommend continuing with all the nutrient control measures that the district is taking because we do want to prevent a return to the conditions we saw in the 1940s and 50s when the water quality of the lake was even worse than the current conditions. However, School Lake may have difficulty reaching phosphorus levels below Minnesota state standards. So we suggested they consider working with the Minnesota Pollution Control Agency on what the agency refers to as a site-specific standard. These site-specific standards will be allowed if the district is able to demonstrate that the reference condition of the lake, so basically the condition before major land use impacts in the watershed, is above the current standard. So this is just a little snapshot of some of the stuff we've been doing there in the St. Croix Valley and some different recommendations we've been making for lake management. Next slide. So now I want to switch gears a little bit to a large project that's received numerous years of funding from the National Science Foundation. We at the research station have just gotten involved in the last couple of years, and this is the Neotoma Paleoecology Database. So I'm going to read you the mission statement for Neotoma, and it's probably going to sound like just a lot of words, but we'll kind of break it down and talk about what this actually is. So the mission of Neotoma is to support global change research by providing an open, community-curated repository for multiple kinds of paleoecological data. So let's kind of digest that a little bit. So first, let's talk about paleoecological data, which is kind of the crux of this database. Paleo means past. So we're simply referring to any type of data that informs us of past environments. This could mean our diatom data from sediment cores, any of the other types of sediment core data I alluded to in the Comfort Lake project, such as other algal remains in the sediments, our geochemistry measurements of the sediments, plant remains in the cores, or even our lead-210 data that we collect to date our sediments. This could also be data from mammals, birds, or reptiles, such as fossil bones and teeth. So really any data that gives us information on past environments. And there are many different types of data sets in this database. And when we talk about this database being community curated, what we mean is that the data sets are uploaded and curated by different members of the scientific community who are experts in these individual fields. So for example, Mark, Adam, and I have all been trained on proper data entry to Neotoma. We're now considered Diatom Data stewards or data experts, and we're able to upload our data sets to Neotoma, and we're also able to help other colleagues upload their Diatom data sets to Neotoma. And when we say this, this database is open, it means that the data are freely and immediately available online. I'll also mention that a lot of our work at the research station tends to focus on the recent past, the last couple hundred years, but data sets in Neotoma span the last 5 million years of the geologic record. So there's really a lot here. And I should also mention the name, the reason it's called the Neotoma Paleoecology Database. Neotoma is the genus name of the pack rat. And the pack rat is actually very valuable in paleoecological research. The pack rat forms middens or nests, and they form these nests from plant materials really close to them, so within a very small radius. And then they cement the nest with urine, and the midden can preserve for tens of thousands of years. And scientists can date and study the middens, and it will tell them what plants were in that area at that time. So studying these pack rat middens are basically another way to reconstruct past environments. So over all the years you may have been coming to Friends events, you may have thought that some of our diatom research is a little bit obscure, but I want you to remember that there are people out there studying pack rat middens. So then maybe fossil algae won't seem like such of a stretch in the future. So again, the mission of this is to support global change research by providing this open, freely, immediately available, community curated by experts in the field, repository for multiple kinds of paleoecological data. So let's go to the next slide and take a look at the database. So this is available freely online. You can go to neotomadb.org, and this is what you're going to see on the homepage. I threw a few metrics in here, which I then realized are actually a year old already. So these numbers have grown, but as of last May, there were 7 million data points, over 7 million data points in Neotoma, and that's grown and is growing, representing over 38,000 data sets from over 18,000 sites around the globe. And so Neotoma is becoming widely adopted by those doing paleo and global change research. There's been many recent talks and publications using data from this database, and it's also becoming a really valuable teaching resource. So going back to the homepage here, if you were to click on the Explorer icon, which is circled in red here, it will allow you to search the database. So let's go to the next slide. And you can search the database in many different ways, by an individual species name or a type of data. So you could pull up all of the diatom data if you wanted, or by a scientist who's associated with that data set. Here, I'm showing the results of a search for Bone Lake, which we just talked about in the Comfort Lake Forest Lake Watershed District project. So you see this is Bone Lake in Washington County, Minnesota. And there are 4 data sets associated with Bone Lake that I've circled here. One of them is the diatom data we collected in 2019 that I was just talking about. The other is the lead-210 dating model from that same core. And I'll come back to the other 2 data sets in a minute. If we were to click on the diatom data from 2019, here's what we'll find. Let's go to the next slide. First, you'll notice in the red circle here that all of the data we upload is associated with what we call our constituent database. So everything will be labeled as St. Croix Watershed Research Station of the Science Museum of Minnesota. And this is basically just our raw data. There are rows of diatom species names, and the columns are counts of those species from individual core sections. And you could actually go ahead and just dump this data right into Excel if you wanted to do something with it. I'll just note that this Neotoma Explorer option is a great way to search and view data sets, and you can bring them to Excel, but there are also much more sophisticated ways to extract and combine large amounts of data from Neotoma. Let's go to the next slide. And so this is just backing up to that Bone Lake search I showed you a minute ago, and you'll remember that there were two other data sets for this lake. There's a water quality data set and another Diatom data set, both from 1983. And when I entered these data sets a few months ago, when I was entering ours, it was really interesting to see the 1983 data there. And this work was done by a colleague, Dick Brugum, who's retired from Southern Illinois University. Mark and I both know him and are aware of the work he did in Minnesota around that time, but neither of us had remembered that he had worked on lakes in the Comfort Lake Forest Lake Watershed District. So it's really valuable to have these data sets in the same place where they can be so easily referenced and compared. Next slide. So just to reiterate why we feel this is so important, first, we're really leveraging our collections here. We have so many diatom slides and sediment from core sections archived at the research station, and this is making information from these collections available to the broader scientific community. And along those lines, I kind of like to think of this as giving our work a second life. So in the example of Bone and School lakes, data we collected and analyzed to draw conclusions about a watershed in Minnesota can now also be part of a larger regional, continental, or global synthesis. And what's also really important is that valuable data sets are being curated instead of lost when a researcher retires. For example, Dan Engstrom started dating lead-210 cores at the station decades ago, and we are now archiving all of those data sets in Neotoma. And finally, we just began to contribute, but we're not just contributors, we can also be users of this really vast data resource. Next slide. And this one I actually threw in just at the last minute. There's very recently, over the last couple of weeks, there was an article came out in the journal Science called Global Acceleration in Rates of Vegetation Change Over the Past 18,000 Years. And the lead authors here, many of the authors have been very involved, and some were the creators of the Neotoma database. You'll see in the acknowledgements I have here, the data for this analysis came from the Neotoma Paleoecology Database, and they specifically mention the constituent databases that they used in their analysis. So this is the type of acknowledgement that we would see for the research station museum when our data is used. And I thought this example was really great too, because National Geographic just picked up this story over this past week or so. So these data are really starting to be used, and I think a really interesting way. Next slide. So before I turn things over, I just want to thank everyone who's been involved in these projects. Both Mark Edlund and Adam Heathcote are very involved in both of the projects I've been talking about tonight. Many others from the station have contributed as well. We received funding from the Comfort Lake Forest Lake Watershed District to work there, and our funding for Neotoma has come from the National Science Foundation. We've actually been really fortunate to receive 3 years of funding to be archiving all of our data sets, which is great because it's a pretty decent task. And thanks to all of our project partners, I mentioned the University of St. Thomas, the Academy of Natural Sciences of Drexel University, the University of Wisconsin, and actually quite a few others through the Neotoma project. So thanks so much for listening tonight. It was really fun to be able to talk to all of you. And I would like to turn things over to my colleague, Elena Feedy, who is the operations manager at the station. Elena is going to be talking about the Pine Needles Artist in Residency program. Elena?
Hello, everyone. Just wanted to remind you, if you have any questions regarding Joy's talk, please put them in the chat window right now so you don't forget them by the time I'm done here. Again, as Joy mentioned, my name is Elena Feedy, and it's wonderful to see so many of you again in person. Well, okay, digitally in person. As you may know, as operations manager of the research station, I wear many hats, one of which is the program director of the Pine Needles Artist in Residency program. It is now in its 20th year with 7 artists this season, 3 of which were deferred from 2020's postponed season. Tonight, I would like to introduce to you our 2021 artists. Guy, if you could advance to one slide. All right. First up, we have Sarah Lilja. She was our very first artist this season, started late April, and just concluded in early May. She is a nature photographer from Lake Elmo, Minnesota. Right now, we currently have Mark Odegaard in residence. He is a mixed media and digital artist from Columbia Heights, Minnesota. And he wraps up his residency at the very beginning of June here. Next slide, please. After Mark, we have Jill Swenson, a writer and author from Appleton, Wisconsin. She has a June residency where she plans to finish writing one of her books and complete some more essays. Dee Etzweiler, I hope I'm pronouncing that right, I think I am, is a digital artist from Eugene, Oregon. She is making the trek all the way over here in her car for a 3-week residency in early July. Next slide, please. Mary Flume Peterson is a journalist and author from New York, New York. She is an NBC producer and will be using her residency to complete a script for a TV series that she has in mind. John Pearson is a printmaker from St. Paul, Minnesota. He uses found and collected objects that he then brings into the studio to create his works of art. Next slide, please. And our 7th and final artist of the season is Cynthia Dix Dickinson. She's a photographer and digital artist from Edina, Minnesota, and she concludes our season in September and ending in very early October. So hopefully it won't be too chilly for her at the Pine Needles cabin. All right, let's see. This is not all of our Pine Needles program. We actually have at the Science Museum of Minnesota a retrospective of pieces donated by our Pine Needles artists since the program began. To tell you a little bit more about it, I'd like to share the video featuring our friend and colleague, Sharon Mullman. Sharon started the research station in 1993 and developed both the Artists at Pine Needles program and the Friends of the Research Station group. In addition, she supervised many programs and special events during her tenure, including the annual St. Croix River Research Rendezvous. I dare you to say that 3 times fast. As assistant director, she also managed administrative and programming operations at the research station. She retired from her role in 2018, but continues to be a friend and booster of the St. Croix Watershed Research Station. Welcome, Sharon.
Hello, I'm Sharon Mullman, retired staff from the St. Croix Watershed Research Station, where I was the founder of the Artist at Pine Needles residency program. In the 1990s, local historian James Taylor Dunn and his wife Maria donated their Pine Needles property and cabin to the museum. At that point, we looked for a use for that property, which would honor their gift and also build upon the scientific programs of the research station. This Artist in Residency program integrates the creative processes of art and science and fosters a closer relationship with our neighbors and community. Since 2001, Artists at Pine Needles has hosted over 50 artists and writers who have further developed this now widely recognized connection between the arts and sciences. Participants in the program have said that access to our scientists inspires their work, and the station scientists have both been intrigued by the artists' views and challenged by them as well. These painters, photographers, poets, novelists, sculptors, printmakers, and more have created not only amazing works of art, but also a synergy between their art and the science of the research station. Today, I'm going to share 3 works with you that have special meaning to me. I also invite you to come to the museum and visit the exhibit to see more art from Pine Needles and learn about this unique collaboration between artists, scientists, and the landscape at the St. Croix Watershed Research Station. In 2015, Joshua Cunningham created this landscape view, which is a classic view of midsummer St. Croix River from the bluff just outside the door of the cabin at Pine Needles. This is a view that nearly all of our residency artists depict in some way. Joshua is a classically trained plein air painter. He creates and captures his images in real time, on site. Mark Edlund, a senior scientist on our team, chose this piece as one of his favorites, citing the iconic quality of the view. Mark also noticed that the daylilies in the foreground of the painting are a garden invasive, which brings the viewer back to the reality that people are also part of this landscape. Poet Sue Smolin and painter Jessica Zeglin did not meet during their separate residencies in 2013 until the fall of that year. We brought them together in a program for the friends at the research station to share some of their experiences. After they did so, Sue asked Jessica to illustrate her forthcoming book of poetry with works based on both their residencies. Together, they captured, through word and paint, the organisms, ecology, resource threats, and beauty of the St. Croix. Their work combined science, especially paintings based on microscopic views of diatoms, a type of algae with a cell wall made of silica, with art and poetry to expand its appeal to a broad audience. Moira Bateman uses the most simple of algal life forms, the microscopic cyanobacteria, to inspire and create this larger-than-life wax cloth piece. Moira uses natural tannins and sediments from bogs, rivers, wetlands, and lakes to dye the silk for her artworks. She says she gives away some control of her artistic process to nature in this way. Thank you for joining me to preview this exhibit. Seeing these pieces gathered here at the museum reminds me just how impactful this program has been. From the artists who participated, to the scientists who generously shared their work and expertise with the artist, to the community members who've welcomed the artists to the area, Artist at Pine Needles has become part of the cultural fabric of the greater St. Croix Valley. I hope you'll take time to enjoy all of these pieces at the museum. The exhibit will run through early September with new pieces arriving in July. So be sure to visit, maybe more than once. And while you're here, you can learn more about the research happening at the research station and the team of scientists who makes that possible in the Science Superheroes Gallery nearby. Thank you for your support of the research station and the Science Museum of Minnesota.
Okay, thanks to all the speakers who spoke to you live or recorded a segment for us, and thanks to all of you for joining us. Now we're going to come to what will hopefully be the fun part of the evening, or another fun part of the evening, where we do an open Q&A. So hopefully you've been typing your questions in, and if not, go ahead, it's not too late, type them in, and Aaliyah Vinnick, who will be moderating, will read them and direct them to the person that needs to answer, or that can answer them. So just as a reminder, these questions can be about any part of this program. It can be about Joy's research talk, about the Barry and Sean's conservation easement, about what's been going on at the research station, or any questions you have about what we've been up to over the last 17 months. So Aaliyah, take it away.
All right, the first question is for Joy. And the question is, how long will it take to reduce Bone Lake's TP for 40 to 30 ppb? I'm hoping you know what that means, because I'm not sure I do.
So for Bone Lake, I think they're hovering right around the state standard of 40 right now. Mark might have to help me out here to remember some other specifics that they're actually, I'm trying to remember exactly what nutrient control measures they have in place. I don't have an exact timeline from when they might go to 40 to their goal of 30. Mark, are you remembering exactly what management they have in Bone Lake off the top of your head?
Yeah, they do have some watershed management and working with the landowners around the lake. One of the issues that we've run into is in Bone Lake, zebra mussels have recently been introduced, which is going to be a game changer for it. It's probably going to force us to rethink what the future of Bone Lake is going to be like. So that's a new twist that is unfortunately becoming more common in many of our Minnesota lakes.
And I do think some of that, when we had said the water quality was poorer about 50 or 60 years ago, a lot of that I think was associated with some of the shoreline development around the lake. So as Mark said, as they've been working with homeowners, things have been getting better and decreasing. I don't really have a timeline for when they might reach the district goal, but it's definitely continuing to move in the right direction.
All right. The next question here is also for Joy. What do we know about phosphorus sources into bone and school lakes in earlier eras, especially during early settlement?
So I think one of the things, and one of the kind of the differences here between Bone and School Lake is that, I need to keep them straight in my head, School Lake, which we've said has been higher in phosphorus throughout the period that we studied, is draining a much larger area than the other lake is. It's sort of part of a chain of lakes. And so it's receiving a lot of inputs from the watershed and from upstream lakes. I think that might be one of the issues in that lake, is that it's sort of the amount of phosphorus it's receiving from a larger land area. Neither of the lakes are particularly shallow. A lot of times when we see lakes that have been productive historically, have had high phosphorus levels, historically they're a bit shallower, and the phosphorus tends to keep being recycled and reused by organisms. But these lakes aren't incredibly deep, but they wouldn't be classified as shallow. So I think a lot of the problems with the one lake that stayed productive is the amount of area that's draining to it. Mark might have something to add to that as well.
No, I agree with you. And the other thing that's problematic about the future of these lakes is they're at this sort of magic depth where climate change is also going to be a factor in these lakes. Much of the other work that we've been doing at the research station has been focusing on trying to understand through using high frequency monitoring buoys like we were just installing in Forest Lake today, to better understand how weather patterns and climate are affecting our lakes. And as climate changes, it affects how nutrients are cycled in lakes as well. So.
All right. I've got just a couple more questions here. One comes from Sarah Lilja. I think this one also is going to go to Joy. Why are Comfort Lake and School Lake so different, even though they appear connected and part of the same watershed?
So I think it's part of this drainage a little bit too, where School Lake is just receiving a lot more of the inputs. I think that might have something to do with why the historical numbers were so different. Bone Lake had lower phosphorus levels in the past, and then peaks that we could associate with sort of the intensification of agriculture or shoreline development, and they've come down a little bit, but again, are still a little bit elevated from those things. But I think that the real difference in the baseline between the two lakes has a lot to do with the area that they're draining. I think there's multiple lakes that are draining, I want to say almost like 10 lakes that are actually in the chain that are draining to School Lake. And I think that's the big difference in the baseline between the two.
Right. The last question comes from John Goodfellow, who says, early discussion of the conservation easement included that the financial benefit would accrue to the research station. Is that still the case? And I think that one is for Barry.
Great, thanks so much for that question. I would broaden that a little bit and suggest that much of that will be used as part of that Wilder project that I referenced. But please be certain that all of that will be used in furthering our science mission as part of the museum's focus on science education centered on equity.
Great. Adam, I'm going to hand it back to you to wrap up. Thanks everyone for their questions.
Thanks, Lilja. Thank you again all for joining us and for your support of the research station and the Science Museum over these many years. We have lots going on, as tonight demonstrated, and we are excited for the future. We're also very excited to see you all in person again. We can't do this alone, and if you haven't already, please consider making a gift to renew your Friends membership. I'm fairly certain that we will host an in-person Friends event sometime this year, hopefully early this fall. So stay tuned for more details on that. It's friends like you all that help us continue to do the science, as you well know, as we've said over and over again over the years, that help protect our lakes and rivers. So thank you and have a good evening.